6-7 radicals review guide. So we're going to start off with some exponent properties, which you can see here. So question 1 and all 3 pieces of it really challenge you on quotient property, where you are subtracting the exponents. So for the first one, it doesn't matter that they're numbers. I'm still going to make it 4 to the 7 minus -8. That minus turns into a positive, which would give us 4 to the 15th. We do nothing with the 4s. They don't cancel, but we keep the base the same. So once we go on to the second one, we've got x to the 1st over x to the 5th. X to the 1 minus 5 gives me x to the -4. But we know that we can't leave negative exponents in our answer. So this is going to be 1 over x to the 4th. If I move everything from the top, I need to put a 1 in its place. And finally, we've got 2 to the 8th minus 1, which gives me 2 to the 7th. For the ones that are numbers, so for 4 to the 15th or 2 to the 7th, you could actually put what the number is. So like 2 to the 7th, that would give you 128. I think 4 to the 15th would give you a massive number. You could put that number, although leaving it as one of these would be just as good. Now that we are on to question 2, we've got more exponent properties. Part A, we are looking at product rule, so that means we need to add the exponents together. The tricky part for this one is that we need to find a common denominator between those two fractions. So the common denominator will be 6. So this one is good to go. That means I have to determine what do I need to multiply each of these fractions by to give me 6, or this one specifically. So I'm going to multiply it by 3 over 3. So what I'm going to add is y to the 5/6 plus 3/6, which gives me y to the 8 over 6. Now be careful with this one because 8 over 6 can be reduced further to give us our answer of y to the 4/3. For part B, as we move on, we've got power property that we have to do first before we do product. So don't get thrown off by the fact that these are 5s. Similar to what we talked about above on question 1, treat them as if they were variables. So this is going to give me 5 to the 14th times 5 to the -6. When we do product rule, we add the exponents. So 5 to the 14th plus -6 gives me my answer of 5 to the 8th. Now, you can evaluate that and make it 390,625, but honestly, once you get to this point, probably easier to just stop. Moving on to question C. We're going to start by getting the top part of the fraction, the numerator, as simple as we can. Then we can start to simplify. So this is going to be 12 p to the 9th. P to the 7th times p squared gives me p to the 9th. Then q over 8q to the 5th. So I'm going to start with the fraction part. I know that 12 and 8 have a 4 in common. So when I start to reduce, I'm going to get 3 on top, because 12 divided by 4 is 3, and 2 on the bottom. So 3 over 2. I don't have any other p's to simplify with, so that's going to stay on top. Then I'm going to move over to the q. So this q has a 1 on it. 1 minus 5 gives me -4, but then I'm going to swing it down to the bottom, q to the 4th. If I notice from the start, I start with more q's on the bottom, so I'm going to end with more q's on the bottom. For part D, this is all power property, so we're going to give this exponent to all of the terms on the inside of the parentheses. The key for this one, though, I need to keep that -3 in the parentheses when I evaluate -3 to the 4th, because that's going to give me a positive number. So be careful with that when we do it. But then it's going to get m to the 4th, n to the -20th. -3 to the 4th is going to be a positive number. It's going to give you positive 81. And then finally, to make our answer complete, we need to swing this end of the -20th to the bottom to give us 81 m to the 4th over n to the 20th. Going down to questions 3 and 4, these ones are just rewriting each of the expressions below in the opposite form. So question 3, we're writing them using fractional exponents, and then number 4, we're writing it in radical form. So the first thing that we're going to do is identify the base. So the base here is 2, the exponent is 5, and the index is 3. We're not simplifying it from here whatsoever. Sorry about that. We are only rewriting it in the opposite form. The next one, the base is 3. We've got an invisible 1 as the exponent and invisible 2 as the index. And finally, the last one will be x to the 4 over 5. Again, you're not simplifying, you're just writing in that opposite form. These ones should be really easy questions that you should be able to do very quickly. So for number 4, when we're writing in radical form, the first thing that you need to have is a radical. So make sure that we add that in. Our base is x. We're taking it to the 6th power, and our index is 7. For the next one, again, I need my radical. 4 is my base. 9 is the exponent. This one, I'm not going to put the 2 there. If I put it, it's not wrong, so I could add it in, but a square root does not need to have 2 as the index written. For the last one, again, I'm going to write my radical. This one we have to make sure that we keep 5v in parentheses as the base. If you left it off, it would be wrong, but 11 is the exponent and 3 is the index. Both problems 5 and 6 are going to ask us to simplify the radical expressions. So now we're going to start to break them down into their factors. So I'm going to start with 176. I know that 176 can be 2 and 88. 88 can be 4 and 22. 4 can be 2 and 2, and 22 can be 2 and 11. So I'm looking for a group of 4 because the index is 4. So I have this group of 4 2s that matches and an 11 that will stay behind. So I'm going to bring out the 2 in front, and then 4 through of 11 will be left over. I'm then going to go through and divide our exponents by 4 and ask ourselves, how many times does 4 go into 8? That's twice with no leftovers. 4 goes into 11 also twice, but this time we have 3 left over that stay on the inside. The second one is going to be the same thing. I'm starting with 72. For this one, I am going to intentionally pick 36 and 2, which will make 36, 6, and 6. Now, I know that I can break down 6 into 3 and 2 for each one, but notice that I already have a pair, and my index is that invisible 2 out front. So I already have that match that I'm going to bring out. So 6 comes out front, and then square root of 2 is left behind. We're then going to go through and divide our exponents each by 2. 2 goes into 9 4 times with 1 left over. The y has an invisible 1 on it, and when I divide it by 2, 2 cannot go into 1, so that y is going to stay on the inside. Question 6 will turn into a problem like question 5 once we multiply them together. So for the first one, this is going to be the cube root of whatever gets multiplied on the inside. 3 times 27 gives us 81. So cube root of 81, p to the 7th, q to the 3rd, r to the 4th. Okay, so we got p to the 7th by doing 6 plus that invisible 1. That invisible 1 plus 2, and so on. And then it turns into a problem like we just saw. So I'm going to break down 81 into 9 and 9. The 9s can go into 3 and 3. So I'm looking to I'm looking for a group of 3, so those 3s match with 1 left over. So 3 out front, cube root of 3 left behind. Then I'm going to divide each of my exponents by 3. 3 goes into 7 2 times with 1 left over. 3 goes into 3 1 time with none left over. 3 goes into 4 1 time with 1 left over. The second one up there is going to be the same thing. This one has some values in front that we have to multiply ahead of time. So I'm going to make it 6 and then the square root of whatever's left. 25 times 20 gives me 500. And then we have x cubed, y. But then the inside part we break down like normal. So 500 is going to be 105. And I did that intentionally because I know that 100 is a perfect square. That gives me 10 and 10, which already matches. So the 10s I'm going to bring out front. We will eventually multiply it by the 6 that's already there. But then we're going to have a 5 left over. So square root of 5 left over. I'm going to divide my exponents by 2 because my index is that invisible 2 out in front. 2 goes into 3 one time with 1 left over. The y has an invisible 1 on it. If I divide that by 2, 2 cannot go into 1, so it stays on the inside. The last thing we're going to do to finish it out is multiply the 6 by 10 in front. So our answer is 60x square root of 5xy. For question 7, we are solving each of those equations. The first one for number 7, we have not seen a problem quite like this yet, but we'll see once we get to the end that it's really not that bad. But step number 1 is always going to be to isolate the radical. So to do that, I'm going to add 9 on both sides so that we're left with the square root of 3k squared minus 15 equals 9. Now that the radical is isolated, I can raise each side to a power. The power that we pick is whatever the index is, so we're going to be left with 3k squared minus 15 equals 81. And then I can go ahead and simplify from here. To do that, I'm going to add 15. So 3k squared equals 96. Then we're going to divide both sides by 3. So that k squared is equal to 32. So if that square was not there at this point, I would be done, but now I have to square root both sides. So this kind of combines a few of our different skills. 32 is not a perfect square, but I can break it down into 16 and 2. 16 can be 4 and 2, or 4 and 4 rather. So the 4s match and will come out front. When we take the square root of a number, we need to have plus or minus in front. 4 will come out, 2 stays behind. And that gives us our final answer. For the next one, it's much more straightforward. To start it out, we're going to divide both sides by 2 to isolate the radical. So we're left with 3 equaling square root of k plus 6. Now we can square both sides. So we should be left with 9 equal 2k plus 6. To get k by itself, we would subtract 6 on both sides. So k should be 3. You are not going to have any on this test that would give you an extraneous solution, so you don't have to worry about that, even though we learned it. Question 8 is very similar to the process that we did in 7. Now we're just dealing with roots that are different than square roots. So we have a cube root and a fourth root. But we're going to start it the same way. Our goal is to isolate the radical. So I'm going to start it off by subtracting 11. So 3 is equal to the cube root of x minus 5. Now we can raise each side to a power, but this one is going to be to the third since our index is 3. 3 to the third is 27. And if it's equal to x minus 5, to get x by itself, we would just add 5 on both sides. So x would be equal to 32. Moving on to the next one, our goal is to still isolate the radical. This one we have to subtract 1 first. So we're left with 2, fourth root of 2x plus 4 equals 4. Then we would divide by 2 on both sides. So fourth root of 2x plus 4 equals 2. And finally, now I can take it to the fourth power. So we'd be left with 2x plus 4 equals 16. Again, this is 2 times 2 times 2 times 2. Now I can get x by itself by subtracting 4. And finally, getting x by itself by dividing by 2. So x equals 6. Question number 9 is again a solving problem, but now we're solving with a rational exponent. So to start it out, my goal is to get the parentheses by themselves and then take it to the reciprocal power. So I'm going to start by dividing both sides by 3 so that we're left with 28r minus 3 to the 3 halves is equal to 729. So then we can raise each side to the 2/3 power. So 28r minus 3 is going to be equal to 81. Notice for this one that our denominator that we're raising it to is an odd number. So we do not have to include the plus and the minus. We just solve it from here. So we're going to add 3 on both sides. So 28r should be equal to 84. And then when we divide 84 by 28, we get our answer. R is equal to 3. When we move on to the next one, we've got a little bit of work to do ahead of time. We don't have parentheses on this one, but we do have to get this part by itself. So to do that, we're going to start by adding 7 on both sides. So that 75 is equal to 3r to the 2/3. Then I'm dividing by 3. So that 25 is equal to r to the 2/3. So now we have to raise it to the reciprocal power, which would be 3/2. And notice that for this one, the denominator that we're raising it to is an even number. So if it's an even number, whatever we evaluate that side to be will need to be both the positive and the negative answer. So when I raise 25 to the 3/2, I get 125. So I need to include the positive and the negative equal to r. The one that you're going to have on the test will look more like the first one.